Hello and welcome to this week's Retrieval Market Demo Day. Today's date is Wednesday, the 8th of December. We've got an amazing lineup today. We've got Ted Liao speaking about Glitter Protocol, and this is a new team introduction. We then have Charles Cowles demoing the latest FS3 work and maybe some other stuff. We'll see how we get on. And then William from Ken Labs demoing Pando latest. Yeah, as usual, please put your comments in the thread on the Filecoin Slack. And Ted, over to you to introduce Glitter.
Yeah, thank you, Patrick. Let me share with my presentation here. Hey guys, we are Glitter. A Glitter network. We are trying to do some indexing protocol on the Filecoin network, and actually currently in the Filecoin network are facing some problems like the data quality. Like there are a lot of useless data on the Filecoin ecosystem. That's why we have the Filecoin Plus program, and we want to incentivize people to uploading more and more useful data. And storage usage rate is now like high, and most important, like most of the data on the Filecoin has never been retrieved ever since they uploaded. And we're trying to solve this by creating a indexing protocol and incentivize user to upload a lot of different kind of useful data. And in this way, we can use massive amount of storage on the Filecoin and facilitate people to download data from the Filecoin and make all the code data become hot. Here is how Glitter protocol works. It is like on this side, this is our miner network. Like these apps are just our ecosystem apps. We want different kind of developers just developing their own apps using our protocol. And like when a user trying to access a piece of data from the internet or from different kind of protocols, if they try to if they try to download some data from the internet or from the BitTorrent network, they can directly check with our miner network and get a piece of data from the Filecoin to see if that piece of data is existing on the Filecoin or not. If it's not there on the Filecoin, then we just incentivize this user to upload that piece of data to the Filecoin. Then he can just directly broadcast that index information to our meta network. This way, we can become some kind of a decentralized version of the indexing protocol across the Filecoin network. And in this way, we are building a bridge between the Web 2 to the Filecoin. And I think in the future we can have different kind of ecosystem apps. Like we can be a decentralized version of the search engine, and we can have the decentralized version of the Netflix or Spotify, and we can have a decentralized version of the download manager. And also we are building this RSS reader for people, like even if the original feed is not there anymore, people can still get that RSS feed from the Filecoin. And also on the Science Hub, and this is the one I like the most. Like we're trying to build this Firefox and Chrome extension. Even if the original website is not there anymore, people can still get the data, like get a snapshot from the Filecoin if we have a copy on the Filecoin. And this way, like I think we can connect. We can build a bridge between Web 2 to Web 3, and this is how our tokenomics works. And like for a data retriever, if they want to retrieve data from the to do some query, like if it's a simple query, like to check this file exists or not, then that will be free. But if they want to do something like a Google-like query, then they will pay a little bit, and they will need to pay a little bit amount of the query fee to the indexer, which is our meta network. Then actually here in the miner will get to decide like how much money or how much query fee they want to charge in the data retriever. Actually, they can directly set their query fee to 0. Like if they just want like actually want all the miners to be compete with each other, and the app developers, like all of the users, they will need to interact with our protocol and the Filecoin via the app developers. So the app developer will also get a cut from that query fee. And also the data contributor, we want to incentivize people from uploading different kind of data to the Filecoin network. And actually, we are indexing a lot of data. The current file size we are indexing right now is like we'll keep indexing them, just keep passing all this data. It is like the current total data being stored on the Filecoin is like 35 petabytes, and so actually we already have our testnet online right now, and like we are start uploading some news and web pages from the RSS reader. Once we start uploading all of this data, I think we can become the single largest storage consumer of the entire Filecoin network. Actually, like we have already we already received some investment from Protocol Lab and Juan Bennett personally, and ZX is our advisor now. And I think we can help the Filecoin, we can grow together within the Filecoin ecosystem, and make all the data stored on the Filecoin be alive. And here, like we hopefully we can become the indexing hub between the Filecoin and all the existing different kind of data protocols. And I think by the end of next year, we'll be able to index almost all of the internet web pages on the Filecoin and put them all on the Filecoin. And currently we are testing our testnet and start uploading some data to the Filecoin. And this is our plan for the next year. And let me check with the progress here. Approval. Yeah.
Oh, I think it's breaking up a bit, and we've lost the screen share.
Oh, hold on a little bit. Let me share with another one. This is our. I just get connect this with our RSS reader. Previously this is not a decentralized search. Right now it is. It is like connect with our testnet, and like you can do some search. So this is a result. Like I just have all the Twitter from Juan Bennett. So if you search the Filecoin in our testnet, then you can get a lot of tweets from Filecoin and from Juan Bennett, and like you can just this kind of search result. And right now, like all these web pages are waiting in a line to be mined on by the miners, Filecoin miners. And we're gonna release our Python and Node.js SDK soon. So every person every developer can just build up their own search engine or get different kind of contents from the Filecoin within one line of code. And this is our goal. And we're gonna have our Python and Node.js SDK out, I think, within 1 month. And please feel free to try it out. And I think we're gonna participate in this demo day for serious different kind of demo days. And that's all for me right now. Yeah. Let me check with no question here.
Awesome, thank you. Yeah, there's a few questions, but yeah, any clarifications that people would like to ask in the recording? No, okay. In which case, I think yeah, move on to Charles and the latest FS3 stuff.
Yes. Hi everyone, and yeah, can you see my screen?
Yes.
Okay, great. So after a very long time development, finally we have the second version of FS3 ready. It's quite easy to understand. So we don't provide any slides, so it will be live demo. We put it already online with a calibration F3 testnet, which means that it's connect to the calibration network. So yeah, we have a public demo account. So people can just access it and try it. So it's pretty simple. Like when you log into the servers, as usual, you have the capability to create a bucket as the same as S3, and you'll be able to upload the file, which well, you know that I download some NFT files from network, so you can choose anyone and upload it. Yeah, so after you upload it, you'll be able to make a online transfer. So let's say like if I wanted to directly back up to a Filecoin network, so we can get, if you know the provider ID, you can use. It'll be like this. This is and then give it the price, whatever it is, and give it a date. Yeah, then you just send it. So you can see the DLC ID created here, and you'll get information. So those data ID will be the one you'll be able to download after setting. But however, this is a V1 version. It's working perfectly, looks nice. Here, what we are bringing now is a V2. The biggest difference between V1 and V2 is that we are be able to schedule a backup the entire instance to Filecoin network. So what you can do is that you can create a backup plan here. Then you can see that I want to give a plan for, let's say, that demo day. And I want to pay this price for backup my storage. And I want to keep the copy on Filecoin network for 185 days. Then I can create it. After you create it, your backup bound will be triggered here, which means that every day at the same time, it will be triggered, it will compress all your data volume, become a car file, upload into a Filecoin network, and doing scheduled job. It will be backup every day. After the backup finished, you can see here, it will have a scheduled backup here. It will tell you finished. You can doing the rebuild images, which means that if you lost your data copy, your entire instance FS3 instance locally, don't worry. If you click the button OK, it tells you that we're doing the rebuild for you, which means that you fetch the backup from network, rebuild the images to recover your previous failure, then you get all your files back online. I mean, entire instance. This is a successful backup jobs we have already done before, and you can check in the history. And this is a new created. It's still in the progressing, and this is the storage provider who is maintained that. You can see it's here. The testnet storage provider open to the public. Anybody can send the DLs to it. And the calibration. It's we have 1 gigabyte network to accept DLs for people testing on calibration if they don't really want to spend the Filecoin official mainnet. So we also give you the ID here, which means that if you want, you'll be able to download a copy here from command line. It's also working. Yeah, so let's see if we get back up to this is the same data set ID. You'll be able to fetch it by yourself as well. Yeah. So this is the fast demo we have, and I think it will be a great product for enterprise usage, and it will be a good use case for Filecoin as a permanent storage, contract-based permanent storage. I don't want to misunderstood by the public. Okay, And yeah, so this is basically like what we have for FS3 v2. On v3, we're going to have v3 launched soon. The v3 will be a cloud version, so people will be able to create their instance on the fly with us. Yeah, here, so I think I still have some minutes, so I wanted to introduce another great product, multi-chain payment. So we wanted to provide a Web3 user interface and to make a payment from Polygon network. So if you log out and just let me log in. Yeah. Okay, I already connected to the network, so I cannot show you how you are connecting. Yeah, so basically you can upload the files. Let's do another image, NFT image. Let's pick up 3 megabit one. Okay, then this is a price by USDC, not Filecoin, but at the back end, we're doing the estimation using the DeFi to doing the replica token from Sushi exchanges, get the price feed. Then you can choose low, average, and high. It's can upload it. You will see that your file is uploading to the IPFS network. Then you need to sign the contract to allow user to lock your funds, because before the deal is made, you are not supposed to pay. If you didn't finish the job, you don't pay anything, and your fund will be refunded after 6 days. You can see your transaction and your contract online here. This is the amount you pay. We create because there's no USDC token on Polygon network now, testing network. So we create our own USDC token. So after everything's done, you can see there, you have your images currently is uploading. It's in processing stage and it is waiting in the queue, sending to the storage server. And you are paid, but the fund is locked for sure. If you go here, you can see the information. You'll be able to download your file from the IPFS network. We're also building a calibration IPFS gateway to enable people upload file to the calibration IPFS network. IPFS doesn't have calibration, but we just name it. Those are the 3 signatures you need to unlock the funds. This is the DAO, decentralized DAO format. You need the key holders to sign the proof of on-chain from Filecoin network. So we get the bounty, joint bounty between Filecoin and Chainic as storage proof provider. So we'll be the data provider to continuously prove the storage of the deal on-chain to Oracle Chainic network. So all the networks people can use this proof to prove that this deal is unpaid already. So it takes a while to get to assign the order. So let's say like one order which is already accepted. For accepted order, you can see the data ID, purpose ID. You can see the deal ID. As soon as it is reached to the clients, we are safely to unlock the fund. If you have 2/3 of the signature approved, you'll be able to unlock the fund. So the fund unlock, you can see here, those are successful deals, fund sending to the storage provider. So as storage provider, you're asked to provide your wallet address so you can receive the funds, wrap the token, wrap the Filecoin from the client. Yeah, that's pretty much about our demo for the payment through multi-chain. Yeah, thanks everyone.
Awesome, thanks so much. I like the IPFS loading wheel. That's a nice touch. Any clarifications people would like to ask at this point? No, all good. All right, William, over to you.
Thanks, Patrick. Okay, let me share my screen. Okay, so this is a follow-up demo that about the Pando metadata service. So in previous demo, I introduced what the metadata service is and the high-level architecture. So in last 2 weeks, we have done a bit of features development, including data backup to Filecoin network. So in this way, consumers should also be able to find the data directly from the Filecoin network with the Pando account. This is done via S3 for now. I'm going to talk about the situation in using the S3 after the demo shortly. So I'm also going to introduce the metrics to help us monitor the system status and the performance of the whole Pando service. Okay, so I'm going to give you a quick demo here. So 2 things. One is I'm going to send some data update from the provider, which is a mocked application. So I run it from my local environment. And then we can observe the data upload to S3. Then we check the metrics. So this is what this is where we usually deploy our application, the service. So this is our Rancher front end. So we can see the logs here. Okay, so now I'm going to the console. And this is the application I used in previous demo as well. We were also going to tweak the usage description a bit in next week. So for now, I'll just reuse this command. So the parameters, the first one is the private key, which is used to sign our request. Then we have the DAG number. So this is how many DAG data we want to send to Pando service. Then we have the Pando peer ID, the multi-address. And the last parameter is a bit tricky for now. So while we are sending the data, the idea is that we want to also wait until the data is fully transferred. So we haven't moved all the functionality to a daemon process. So for now, if we don't have the timeout, it will directly terminate. So let me run it. So this is the output. So you can see here we have 5 root CIDs generated here, which are for those DAG data respectively. So we can see all these CID from the Pando service log. They will be received. So I can check one in the log. So this is the CID. So you can see there are 5. So all the DAG data has been synchronized to the Pando service. So if we scroll down here, and we can see a successful backup. So the data is written to this car file. So this is a timestamp. We can use it to search later in the S3 backend. This is the indication that the backup is successful. So now let's go to the S3 backend. So if we refresh, so we should be able to see the file backup on S3. And these are all the files I think we tested today in these 2 days. So the files will stay on S3. It has the process and the mechanism to upload those files to Filecoin network. So this is how we, as Pando service, back up the data. The next thing is the metrics. So this is what we built. So if I refresh, so if you notice just now, there's 64 DAG persistence count, which means there are 64 pieces of DAG data stored by the Pando service at the time before I trigger the data update. So now there are 5 more, which is the same as the number of the DAG pieces I just produced. And this is how many providers registered. As we are testing, so we registered 7 providers. And this is the subscriber count. We have a interface to allow you the Pando service to subscribe to some providers. So for now, this is the HTTP interface. So we allow multiple subscription to the same provider. So you should be able to see here, this is a bigger number than the register count. So we register same provider multiple times. And this is persistency latency. These are the heat map. The idea is to show the latency on different aspects. You can see here, this is the latest. I think this is what, let me see. Yeah, so you can see this is one persistence. This is a one operation with latency between 500 milliseconds to 1 second, and the one between 200 and 300, and 3 between 100 and 200. So this is how we show and present the latency metrics. So this is a subscribe API. So this is pretty performant, you can see here. So this is a simple HTTP API. So the Pando service can subscribe to some provider. So it nearly just 1 millisecond. This is the register API, it's the same. So it's I did the registration before the demo earlier today. So it showed here, and it also takes nearly no time. And these two are the metadata related API latency. Probably I can also show here. So this is the snapshot list. So these are all the snapshots generated, and each call will be tracked by or monitored. So I just hit this meta list endpoint. Let me do another one to show the snapshot details. So this is the API. So in this demo, I'm not going to cover all the details up in the response. I'm trying to show you the metrics. There may be some delay to see them on the dashboard, but now probably you can still see some blocks here. So these are the call made around 2:30 this afternoon. So this is the indication that it's pretty performant because of nearly no traffic to those HTTP API, and these are the almost in-memory operation. So these are all the metrics we have already implemented. So this is metrics. I also put a screenshot here. And so for next step, one thing is the bug fixing. The other main thing we want to review is the backup solution. For now, all our data backup will stay at the S3 side until it gets uploaded to Filecoin network. So S3 has its own policy mechanism until the total size reached up to 3.75 gigabytes. So all those data will still stay on S3. So we want to measure if this is what we expect. Otherwise, we may need to do the data upload by ourselves to work around the S3 service. So we need to review. And the last thing, the performance test. We have done the feature development. We build up the metrics. So the next step will be the performance test, probably end to end. So we want to see how much data we can store, we can manage, and how many providers, concurrent providers we can support. We haven't covered the consumer side, so that's also part of the work in the short future. Okay, I think that's it. Still thanks to Xiaohua Zhang and Ben, who are the main contributors to all this feature development and bug fixing. Thanks to them. And yeah, I will use almost the same slides at the end. So thank you very much. 谢谢.
Awesome, thanks. Any clarifications that people would like to ask or bring up now before we finish the recording? Cool, all right.